Okay, chapter 4. So chapter 4 is about a couple of statements and also operators for making decisions. So first of all, let's talk about a couple of comparison operators, and they will be used in conditions, which we use to evaluate some expression and then decide what to do. That's how we make a decision. So the comparison operators will got this less than equal to, greater than equal to, equal to. Now remember the equal to here is a double equal sign. It's not the same as the one in math where you have a single equal to symbol. But the single one here in this C++ language is the assignment operator. And you have not equal to. The very last one is a three-way comparison, or nicknamed spaceship operator. And that is one that you can use. Actually, the usage of the three-way comparison becomes more clear when we introduce classes and operator overloading at some point later. And right now, it doesn't seem to be very useful. But I include this here just for completeness. And the book, it does talk about this and have some examples. So the simplest, well, the first type of a statement for making decisions is the if statement. Now the if statement is essentially this format. You have this keyword if, and then you put a condition in the parentheses. And if that condition is true, and then we'll execute a statement inside the if statement. And that's really what an if statement is. Now, of course, and here it indicates this is a simple statement with a semicolon here, and then the other format here, this is a compound statement, actually, where you have multiple simple statements. So, of course, they're both allowed. And this compound statement is also a statement. Then, if the condition is false, what do we do, right? So you could potentially have an else part of that if statement. So you have this if-else form of this if statement. So if the condition is true, we execute the statements here that's corresponding to the if statement. The conditions are true. If the condition is false, and then we'll execute the statements in the else part of it. So that's pretty easy to understand. Well, actually, though, sometimes you don't necessarily use the if-else. Essentially, sometimes what you do, you could potentially don't have to use this else part of it. So if you just write this else part without the else keyword here, right? Essentially, and that will be executed because this is the next in line. If the condition value is to false, this statements inside the if will not be executed, and then we'll go proceed to execute the statements whatever is after, right? So sometimes you may feel this else part is somewhat redundant, but you can use both styles. Just a bit of a note on the formatting in C++. You see most formatting, actually the IDEs that you mostly encounter are going to format the code with the quoted braces on Leo9, the beginning and the end. This is a C++ style. You may have noticed in some other languages where the first beginning brace is put on the same line as the if condition right here. Okay, so that's just a particular convention in that particular language. And then we also got logical operators. Of course, we're talking about this if statement, or what do we do with the condition? And so the condition essentially, what this is it's going to evaluate an expression, and then that expression results in either a Boolean value or something that will be converted to Boolean. Now, a Boolean value, right? It's another data type. It's a fundamental data type that has basically two values. It's either true or false. And both true and false are keywords as well. So the logic operators are there to compose sort of a different parts of a condition. And so you can combine things together. Not unlike what we talk about in the bitwise operators, right? The bitwise operators will also see where you got the single ampersand and single pipe symbols, right? So those are the bitwise that we operate on the numerical values for flags, that kind of usage. So here, this is about Boolean condition. And there is a bit of a difference, though, between the logic operators and the bitwise operators. One of the main differences is that the Boolean logical operators, they have this properties called short circuit. Now, short circuit, what does that mean? So here's an example. So we have an int x equal initialize it with 2, and then we have this expression on the right hand side, and this expression is as you see, there are two parts of this, and they are combined with the and logical and operator. Now the first part of it tests if this x is less than 0, which is this comparison operator here, right? Less than. So obviously this is false. Now, because this is false, there's no need to evaluate the other part. This is now remember this sort of logical AND operator is a binary operator. You got the left-hand side and right-hand side. There's no need to evaluate the right-hand side because it doesn't really matter the right-hand side, whether it's true or false. The end result of this whole expression will be false because the left-hand side is already false. It's evaluating from left to right because that's the associativity rule for this operator. And so this behavior is called short circuit. So and then here's another example with a logical OR operator. So let's, first the left-hand side of a logical OR is comparing, x equal to 2, which is true. And then you got something, after on the right-hand side. And because this is true, is a logical OR, and it doesn't really matter what on the right-hand side is, whether it's true or false, the end result of this whole expression will be true. So there's no need to evaluate the right-hand side again. So that is short circuit. Okay, and then there's also a third logical operator, which is exclamation mark, which does the negation. So it will negate the Boolean value. If it was true, it becomes false. If it's false, it becomes true. And then another operator that can help us make a decision. It's very much operates like a if statement, but this is a much more compact form for typically used for simple compact statements where you have a simple choice to make. If what you need to do tends to be pretty large or really long and big, sometimes for clarity's sake, you may just end up writing an if statement. So this conditional operator, question mark and colon, It takes 3 operands. This is the only operator that takes 3 operands. It's also called a ternary operator. So this condition operator takes 3 expressions, and expression 1, it will either this is a Boolean result, or it will be converted to Boolean, and it will check that. If it's true, it will evaluate the expression 2, and if it's false, it will evaluate expression 3. Okay, so that's really what conditional operator is. Now, we talk about expression a lot. This is it's actually a core concept in the language. Many things are expressions, but not everything are expressions. Now, what is an expression? An expression is a sequence of operators and their operands, and that specifies a computation. So a function call is actually also an expression, because a function call with a parentheses, that is an operator. And if you do an assignment, that assignment is also an operator, and that's also an expression. If you have an expression, now remember, expression you can use in many different places. If your expression is followed by a semicolon, then you just made a statement. This is actually called expression statement. Okay. Another type of statement that we can use to make decisions is called a switch. The switch statement is it's actually it's another form of decision-making statement. You have the capability to test a value and then evaluate different options, like what you can do for multiple different options. Now, of course, you can actually, do the same thing with the if-else, right? But sometimes switch makes it more clear and more compact. And so it's just another format of making decisions, just another convenience. Now, the general form of the switch statement is basically this, right? So you start with the keyword switch, and then you have parentheses. Inside the parentheses, you have 2 parts. The first part is init statement. This part is optional. Now, what can you do with the init statement? For example, you could declare and initialize a variable, and then you're going to use that variable inside the switch statement right away. Okay. Or perhaps you use it in the condition that just follows. And this is has to be actually a simple statement, not a compound one, like with a braces, right? So this, and then after this, you have this condition. This condition is basically something that will be of the Boolean type or enumeration type. Well, no, sorry, it's actually not Boolean type. There's 2 types of value that will take. It's either the integral type or enumeration type. Now, we have studied those already. So that's kind of the sort of the restriction here. It cannot be anything. It has to be either integral or enumeration as a result of that condition, which again, it can be an expression, right? But the end result will be used to make the specific choice in that statement. Now, this statement typically is a compound statement. And this statement also typically contains the case labels. Now, the case labels are the ones that will be matched with the value in the condition. So the result of that condition, if it equals to a particular case value, and then the block of statements in that particular case will be executed. And we're going to see an example shortly. Now, before we get to that, so again, let's actually look at another concept. So we'll talk about statement. Now, what is a statement? A statement is a fragment of the C++ program that are executed in sequence. And there are many types of statements. Well, it's a couple of them. So we have seen actually a number of them already, right? You have declaration statements where you can declare a variable. Optionally, you may also initialize with it. This is usually recommended. And then you have expression statements. And if it's an expression statement, right, we just talk about expression, what expression is. And you add a semicolon to an expression, that becomes an expression statement. And a special case of expression statement is called a null statement. A null statement is a statement without the expression. So essentially, it's just a semicolon. And that's actually usage for that. But again, we're not going to look at the specific cases. But if you just write a semicolon, it's not going to do anything. It's no op. And then there's a compound statements we have seen, for example, all the function bodies, like the main function we have seen so far, that whole body is essentially a compound statement, right? It's marked by that, pair of braces. And then selection statements. So that's really what we're just talking about in this chapter, the couple of statements that we use to make choices, make decisions, and those are called the selection statements. You have an if statement, if else, right? You have the switch that we're just talking about right now. So, and then there's also the iteration statements we're going to look at in the next chapter. This is where we have loops. So it's another essential construct in the language. Now, there's one thing I want to point out in switch. So we said, well, the switch, you have the condition, then that's followed by a statement. Well, we just explained what statement is. You could be having just a simple statement without the compound, and then, well, that would not be very useful if you switch and then you really have no choice to make, and that's not very good. That's why I would say, even though that's legal, but typically you're going to see a compound statement where you also have the case labels. Now, this case with a value followed by a value, and then with a colon, and that's a label. There's actually other types of labels you can make in the C++ program, and then those labels typically used with the goto statement. So we're not going to talk about those here, but within the switch statement, you can use these special case labels. And the case value is what you use to basically compare with the actual value in the condition. So if they are equal, then this case is chosen. And then the block of code over there, starting from that case, will be executed, starting from that. Now imagine if you don't have the break here. If you don't have the break here, it will just fall through. It'll keep executing because these are just statements one follow another. It's going to be just sequentially executed. It doesn't matter how many cases you have following. If you have no break, it will just keep executing from that point on. Essentially, the case labels, much like the goto statement, it provides jump points. So your control of flow jumps to this point. If you have other cases, it may be somewhere in the middle in this many statements. So the mechanism to stop, if you have different cases, say you just only want to execute the portion within that case, which is a lot of times the case. And then also you have cases where you do want to fall through. Okay. So the one that I want to talk about here is this variable declaration. You could potentially declare a variable x here, and it's initialized right here as well. And is this going to be a problem? Yes, it is a problem. The problem is you just declare it is a variable in a specific case, and this case may not be matched. And so this case could be skipped. And then you're going to reach, let's say, the default case, which is the fallback. If you reach here, now, although we're not using x here, but remember, x is just by the position of this where the x is declared and defined. It's within its scope. Now, what's x scope? The scope of x is this curly braces right here. This is the block scope for x. So x is actually visible here in other cases that's below x. And the problem is you could reach to a point in the program like here by this label, the default label, but your x, you could potentially use x here, but then it was not really defined. And so that's the problem. Basically, that's the rule. This is, you get a compilation error. Now, the way to fix that, if you do want to do something like this, is that you got to add another block scope to contain x. So now the scope of x is contained within the case 1, okay? So that would be not a violation. This is fine. So to summarize this chapter, you can compare two values using comparison operators, and the result of that comparison is a Boolean value and have the type bool. And that bool can be either true or false. Now, you can also convert a bool value to an integer value. So true is equal to 1, false is equal to 0. Numerical values can also be converted to bool. And the rule for that is if it's 0, it's a false. Otherwise, it's true. Now, the condition we use in the if statement and the conditional operator, if the expression does not evaluate to be a Boolean value, and the compiler will try to convert. Now, if it cannot be converted, then there would be a compilation error. The logical operators and or not, they are used to actually string together more complicated logical expressions. And then you have the switch statement. That is a mechanism to select one from a fixed set of options. And depending on the value of the expression, which has to be an integral or enumeration type. If it's not of that type, the compiler is going to try to convert implicitly. Of course, if it fails, then that will be a compilation error. So that's it for this. Now, I did say we're going to just look at an example. The book does have multiple examples, but the one that I just want to explain and walk you through this is the 409. And the 409 illustrates actually the if statement as well, the if else, and also the switch statement. And so let's take a look at this. We have a letter char, it's 0 initialized. And then we're gonna take a letter from the standard input, and we're gonna test this letter. And so first I wanna see if the letter is alpha. This is alpha, it's a function in the locale module, the locale library. Now the locale library now what is locale? If you're not familiar with what a locale is, a locale is encapsulation of the cultural differences in a particular country or the particular region. For example, the language, even the dialect of that region, the way the numbers are formatted. You may use a comma to separate groups of 3 digits, or you may use a dot to separate them, and they are very much cultural specific. And some cultures that you group, groups of 4 numbers to separate a big number. And then the format of dates, right? So all those things are part of a locale. So the locale is really a set of facets that describe cultural differences in a particular region. So that really was what locale is. So in C, there's also a concept of locale, but it's kind of sprinkled around in different places. It's not, and so there's a functions that are actually defined, and you'll notice that the book uses is alpha from the C type library. And if you write a C++ program, I would say, you should prefer writing the C++ mechanism. So for most of the C features, C++ has provided a better substitute. So here, that's why I modified whatever the book provided to use the C++ way. And so this is alpha. We're testing this letter. Now, of course, whether this letter is alpha or not, that can be locale specific. So over here, it takes another argument here. Here we're just using the default locale. This default locale, effectively is the C locale. So C++ provides a mechanism to basically try to be compatible with the C. So the specific details you don't have to worry about, but here you just know that we can actually pass different locales. So you can internationalize your program if you want to. Now, so we test this if it's alpha. If it's alpha, we'll do something here. If it's not alphabetical, then we just say you did not enter a letter. Like for example, you entered a number and there's not. So if it is alphabetical, is a letter, then we want to see if it's upper or lowercase. Well, no, sorry, not upper lowercase. What we're testing here, though, is we're testing if this is a vowel or consonant. Now, to simplify, we first convert that letter to a lowercase. So this is what this function is. This is to convert to a letter to a lowercase. Now, so that when we write out this switch statement, we don't have to worry about capital A, E, I, O, U, right? So we have 5 cases here. A, E, I, O, U, there are vowels, otherwise they're consonants. So, okay, of course, these rules here we're describing, it's only makes sense in English. So this is really what this program is. So if this letter after it becomes a lowercase, it matches one of those 5, and then maybe you've noticed if it's A, it's gonna fall through. It's gonna keep going. Now, even if you have some statement in between the cases, this is formatted in one line. You can break them down into different lines if you want. It's going to just fall through. Again, these are just labels. There's nothing to execute. Well, the first one is going to execute is right here. Okay, it will execute to say, well, you entered a vowel that will be printed in the console. And right after this, you can return. So look, we actually returned 0. We got out of this main function. So the program basically terminates right here. Now, if it is not one of those vowel letters, and then we'll simply print out, it's a consonant. So now this also feels like if else, right? Isn't it? This is like if it matches one of those, and then we are saying this is a vowel. Otherwise, it's a consonant. So you see how you make different decisions with if and switch. They're just different style. There's just specifically different purposes. Now, we could have written this switch statement with if else, of course, right? It's much more verbose, perhaps. So this is obviously more clear what the intentions are. So, I mean, again, if you run this program, it just does what we just said it's going to do. So I already compiled it. We're just going to execute. So look, it's going to ask for me to enter a letter. Let's say I enter 1. Well, it's not a letter. Okay. So if we run again, we enter, let's say, capital A. It's a vowel, right? So let's say we enter B. It's a consonant. Okay. So the program works. All right. That's it. Thank you.